Okay, let me begin share screen. Yeah, you should be able to see it. And yeah. Um, so today we're going to go through several of the problems that we have question, still have question on the last time. Then we will go on to the new topic, and because the the topic of algebra is actually quite big and also quite difficult. We kind of will just mix different topics in the. I think we will cover all the topic first, and we will go into more of the the testing preparation. Then we'll just deal with different problems and show different techniques. And so um, this first problem basically is a limit. Limit basically you are doing the trend. So what we know is that the numerator is 1 and the denominator is n. And numerator is fixed. So this is always 1. Always 1. And n can go to infinity. So it just became bigger and bigger. So as it go to, for example, you can actually do some, when you do limit problem, you can actually give your data example. For example, how about I start from 1 all the way to 100, then go to 1 million.
I
Then,
can't see the share
oh,
screen.
sure, sorry. Let me begin share screen. And um, yeah, I think I was sharing. Are you able to see it right now?
Yes, thank
Oh,
you.
great, thank you. Yeah, so basically, when we are dealing with the limit, and so we are looking at trend. So, because the numerator is fixed, that's always 1. And the denominator, you can make it bigger, like 100 and 10,000, how about 1 million? So you will see that it's smaller and smaller. It's really, if you really draw a dot starting from 1, this is 1/2, 1/3, and all the way. So it's a limit is just a trend that will going to stop at a fixed number. In this case, the fixed number is 0. So you know at least we know that no matter how big this n goes, the whole number will always be positive. It will never reach 0. On the other hand, it will be smaller than any small number you can name it. So it's basically, the limit is 0. And these are the same. Basically, for if you have n squared, it's just go to 0 at much faster rate, and n to the cube also is the. So this is, generalization, basically, limit like n to infinity and n to any power k, if the k is an integer, or actually, in fact, k does not have to be an integer. K, as long as it's a, like, if k is greater than um, greater than 0, so basically, even it is a fractional power, it's still going to go to infinity, because when n goes to infinity, into the case will go infinity, and then the whole number will actually go to 0. So let's trying to do this problem, and this problem is actually is very looks very daunting, and this type of problem and limit, especially the problem if the problem is at a certain number. And when you're trying to fill a hole, usually it is continuous. So it's continuous elsewhere. And the only thing limit this one not able to get a value is that, the denominator cannot be 2. The denominator cannot be 2. Sometimes if I graph so basically let me graph I think I to prepare this class, I actually did a preparation for this. So basically, if I graph y equals square root of 2x plus 5 minus square root of x plus 7 divided by x minus 2 is actually a continuous curve. So at x equal to 0, it's about 0.5 or 0.2. So why does this happen? So usually so in this case, it's actually, at x equal to 0, it does has a continuous value. So how are we going to deal with it? With this, it's a basically, x equal to -2. In normal case, it's going to cause a singularity. Basically, will go to infinity. It didn't go to infinity. For example, if you say if I say 1x, 1 over x, basically at x equal to 0, it will be a hyperbola, and it will go to infinity this way and go to infinity. It's actually going to go to infinity in 2 directions. One direction is that approaching 0 from positive, it's going to go positive infinity, and approaching it from negative direction is going to be negative infinity. So basically, it didn't happen on this curve. And what does it tell you? It usually tells you that, on the numerator, it has a hidden x minus 2, which can cancel the denominator. So basically, we will find out this x minus 2 on the numerator. So normally you will like rationalize the denominator, but when you do limit problem, a lot of time you will have to rationalize the numerator. So rationalize the numerator in order to cancel out the 0 on the denominator. So right now, on the denominator, I have the 0 value, basically x equals 2. If I rationalize the numerator, and if I able to cancel out this expression, if I can produce x minus 2, if I'm able to find the hidden. So the clue this expression has a hidden x minus 2 on the numerator. You can easily verify it by doing a graph, and you can easily do graph. So basically you can, on internet, I use GeoGebra, and you can type in the expression and find if, if it has a singularity, if it is a legit singularity, it will show up like this. And another singularity, for example, x 1 over x square, it will just show up like this. It will show, it will approach the positive infinity from both sides. So it will have a singularity, and obviously the function picture don't have a singularity. It is a continuous flat line. So what we're going to do is rationalize the numerator. We're going to multiply to rationalize a radical expression. So this is just, like fun part of the algebra. And so algebra, basically, they have a concept of conjugate. So conjugate is used to introduce the difference of square. So basically it's the difference of square. Because we have a square root onto number, and if we multiply this, So the k is still a mystery number, but other than x equals 2, anywhere on that line, when x is not equal to 2, we can multiply 2x plus 5 and plus square root of x plus 7. So this expression is the conjugate of this. So basically let me use a different color. So basically I can write above this line without, so it's 2x plus 5 square root and minus. So this is just, I copy it down, x plus 7 and all over. And this is, so I have to multiply this conjugate on both numerator and denominator. So this is how I will do it. And this is x minus 2. And this here on the top, basically, because of different square is that a square minus b square equal to a plus b multiply a minus b. Then basically you will see that it's actually equal to 2x plus 5 minus and x minus 7. So this is the expression you have. And when you minus it, you is actually x. And this is going to be, this is plus 7. Plus 5 minus 7 going to be minus 2. So basically we revealed a hidden x minus 2 on the top. So the whole thing, will become x minus 2 on the top. On the bottom, it's going to be x minus 2 multiply 2x plus 5 minus x minus 7. So basically, I can cancel this. The logic behind it is that, no matter how close to 0 or no matter how close to number 2, basically those two numbers will be exactly the same. You can actually cancel it. So basically, other than 2, all the number will be continuous. It's continuous basically. The rest of the, if I rationalize the numerator, the whole expression is actually is that like 2x plus 5 plus square root of x minus 7. So the whole thing is actually, on the branch, on this branch, the majority branch actually will look like this. This function actually is continuous at x equal to 2, exactly as if we show in the GeoGebra, graph. So basically, we can actually fill in. We can, even it's not defined as x equal to, I can trying to find the value at, very close location at that number. So like x equal to 2, I fill in that's going to be 9. So, and this is actually plus 7. So 2 plus 7 is also 9. So basically, this is 9 square root is 3. And this is 9 square root is also 3. 3 plus 3. So basically, it's 1 out of 6. So that's, it's going to be defined at infinite close location to number 2. So in this case, the whole line, if you really draw it, it's just a line at 2. It's going to be a hollow point. Since it's both sides approaching from both sides, it's going to be 1/6. If we just fill in the hollow with k equals 1/6, then basically the whole line will be continuous at this point. So this is just the concept of like filling in the filling in a artificial value at a point which is almost continuous. So then this one is that this one basically is also relatively easy. So it looks like a variable, but you possibly you haven't learned about sine. But if you really, sine basically is a trigonometry function. It's just opposite, over the hypotenuse. So if you have a theta, like if this is a right triangle, so basically it's opposite. It's one of the leg. It's one of the leg over the hypotenuse, and so leg over the hypotenuse, no matter what theta is, it's always going to be less equal than 1, the absolute value of it. So basically, the top could be vary between like -1 to +1, but it's never going to, absolute value never going to be bigger than 1. But when going to infinity, the bottom is going to go to infinity. So the top is limited to not exceeding 1, and the bottom is going to infinity, so the whole thing going to go to 0. So that's the way we can do it. And this is another case of so the previous case in 131, we actually rationalize the numerator to get it. And this one is not rationalized, it's factoring, because it actually is higher. The numerator is higher than 2. So basically, we just factor the numerator and find out one of the factor of x plus 2. Indeed, it has it. It's x plus 2 and x square plus 4x. It's not plus 4x. It's actually minus 4x. Minus 4x. Actually, not minus 4x. Minus 2x. It's minus 2x plus 4. So there's how do I know this? Because there's a cubic function. So cubic addition function, or cubic addition, it's called identity. It's the polynomial identity. A squared plus b squared is actually equal to a plus b multiply a squared minus ab plus b squared. So right now, all I did is that, a equal to x and b equals to 2. So if you fill in the formula, you will actually get this. Then is actually x plus 2. Then this actually cancels. So basically, then we just fill in the -2. -2 square going to be 4. And -2 multiply -2 is also equal to 4. So basically, and plus 4. So basically, it's going to be 12. And because we have, 4 plus 4 plus 4. And then let's do this problem. And this problem basically, we have at x minus 16. And basically, you still can, for all those type of problem, if you have doubt, you actually can use, a graphing function. And in this time, we actually, we can factor out x plus 4 and square root of x minus 4. So basically, So if we do this, then we can cancel out the numerator. Numerator became 1. And numerator became 1, then also what magic happens is that, 16 was a singularity here, looks like. It's not a true singularity, but here, after we cancel it, 16 no longer is a limitation here because 16 square root is 4, and 4 plus 4 equals 8. There's no longer a singularity happen at 16. And the 16 was a singularity because if we factor this out, square root of x minus 4, and it is a singularity for this expression only. So basically, this is just way that you can, deal with this type of the challenge. And so it's going to be 1 out of 8 is the limit. Anyway, this type of the problem just, give you sense of the trend around infinity. So this is around infinity or around a singularity. And not all the singularity are discontinuous, So basically not all the so in some case, they actually has a hidden factor which will cancel it out, which make it continuous. It actually has a limit value. So these are the cases we are working on. And so I think let's go on to the polynomial. I think we'll just do 2 of those problems, and we will go on to the new topic. I don't want to spend too much time on this topic. I think we'll bring about 1 problem. I would prefer to bring just 1 or 2 problem each case, because I think this is a difficult topic, Vieta, and plus the polynomial, division and the remainder and all those things. But it's just one of the topic. So plus we actually could achieve a better effect by spreading difficult topic out. Limit is a difficult topic, so we only do 1 or 2 problem each time. So you actually get a long period of time to consider and learn it. Otherwise, if I just spend a huge amount of time in one class, and you will be frustrated about it and totally forget about it. Then for the difficult problem, it's actually most efficient way to spread out in a range of different class, and you learn slowly. So so basically, this type of the problem, we will just have to use the Vieta formula, and we can assume that it has a root R, S, and T, because this is a very legit assumption, because if you have a cubic function and you always going to have 3 solutions, that's always true. And then basically, and 2 of the real root add to 0. So basically you can say that R plus S equal to 0. And that's always true, because it's a given condition. And then we will have the Vieta formula basically is just telling you that the cyclical sum of the root is equal to the ratio of the coefficient. So like cyclical sum basically is like, R plus S plus T. You just have to get used to it. Basically, this is just, it's a very simple idea. Basically, it's just saying that, given the fundamental theorem of algebra for a 3-degree, you have 3 roots. Then 3 roots you actually can write into x minus R, x minus S, and the x minus T. And then add, this is monic, then we have to add a 0. Is actually, this actually could be factored into this format. If this factor into this format, then if you multiply it out, then what will happen is actually, it will have this format. So basically A0, and this is x square, x cube, actually going to be minus. This is like, A1 is actually, has some relationship with RST, because I can divide A0 on across. So basically, it's A1 divided by A0. Actually, here is actually, so A0 x cubed plus A1 x squared plus A2 x plus A3 equal to 0. So this is the generic format, just look like this. Then basically, if you make it a monic, it's going to be x squared x cubed plus A1 A0. So basically, I'm trying to write it out. So basically, you will have more sense of feeling on what the quintessential meaning of this thing. And so the whole thing is very, very simple. The whole thing is just you assume they have root, then it can be simplified in this format. Then if you, on the other side, so this is how the original function looks like. Then if you have those roots, then if you expand the root, it's going to be look like x cubed minus R1 plus, or R plus S plus T and x cubed, then plus, then it's a cyclical sum. So basically RS, plus RT plus ST x, this is x squared, then will minus RST. So basically, if you make the assumption, it's just going to look like this. And because right now this formula and this already synchronized in the format, so basically you are able to link the, so because the x squared is the same, so their coefficient has to be the same. So basically these are the cyclic, cyclic sum of their root. And so basically, given those information, what we know is that A1 is just negative 12 divided by 4, and it's actually very, very easy. So basically, when you have difficulty remembering like Vieta formula, I always resort to just linear function. So linear function is ax plus b, if you really simplify it to this way, equal to 0. So it's actually ax equal to negative b and x equal to negative b over a. So basically negative b over a is always true, even starting from the linear. So basically, so the cyclic sum x on the linear, it's just, it only has one root, so it has to be the cyclic sum is the whole thing. So the sum of the root is actually, the division of the quotient of the next highest coefficient over the highest coefficient. So this is the next highest coefficient is is negative 12 over the highest. And we have to put a negative because this is, so basically this is actually negative, negative is positive. So basically it's 3. So it's actually, you know, because it's telling you that 2 of the real roots add to 0. So basically r plus s equal to 0, then r plus s plus t is actually going to be equal to this and equal to 3. So basically t equal to 3. And so basically t equal to 3, we actually can plug back in. So basically, you know, and we know that r plus s equal to 0. So basically it's telling you, what it's telling you is that r equal to negative s. And then we can use the product. Product is the last term. The last term basically says that negative RST, if you, this is the cyclic sum of third order. And so basically, you know, A RST is actually, you know, equal to A3 over A0. And A3 is just equal to, it's negative D over A equal to 4. So basically IST equal to negative D over 4. And then we know that R equal to negative S. So negative S multiply S multiply and T basically equal to 3 and equal to negative D over 4. So basically, we have like S then we also have the here it has the relationship. So we also have like C divided by 4. C divided by 4 is just C divided by 4 is just relationship of the A2 divided by 0. C divided by 4 equal to S. So basically it is the R equal to negative S. So it's negative S multiply S. R is negative S, so plus negative S multiply T. And then plus ST. And this obviously you cancel. So basically, you know, C divided by 4 equal to negative S square. And here is D. D basically, you know, we have multiply negative 1 on both sides, we will get this. So S squared basically equal to, I divide by 3 on both sides is actually D over 12. So basically, you know, I have this and this. So basically it's asking me to find D over C. So So right now we actually began to find the clue, because if we divide them, basically the s square will be canceling out. I don't really have to calculate the root. All I need to is just divide them and they will cancel. So basically it's just, uh, like I can um, divide them each other. I will get s squared divided by negative s squared going to be -1. So basically the other is that d over 12, and d over 12 divides this, going to multiply its reciprocal, going to multiply c over 4. And I'm going to cancel this out, going to be 3. So basically d over c over c, and this is on 3. I'm going to multiply 3 on both sides. It's going to be -3. So that's finally we will find it. And this type of the problem is not that too difficult. It's just more of the, like, more of the formula following and the function filling. And what we do is that, starting from this, and right now actually write it out just to refresh your memory, because the Viet formula is always going to, Viet formula has a lower order, like even on the linear and the quadratic. Quadratic is used the most often, but on quadratic, on cube and the quadratic, it just has a more complex form. But you can always remember it. To remember it, you start from the linear, and you can always, if you forget it, you can absolutely recall it by this way. Then basically, it's just a, and it's actually the total. It's a cyclic, or like cyclic sum of the, like the product, cyclic product sum. It's cyclic first order of the product sum is actually itself, because you just, RST, then it's just 2 of the root multiplied together, 3 of the root multiplied together, and all the possible way of multiplying together. So basically this is just the way that you can intuitively just remember it. And then basically it's always starting from negative, so it has a negative. So basically it's the negative. So basically you can just write it out. You can, R plus S plus T equals to, the first one is always going negative like B over A. Then the next one, then you also do a rotation, then it's going to be like C over A. Here is negative, then the next one you don't have negatives. Then the last one is like, is D over A. That's going to be negative. So basically, if you just write it this way, it's kind of, especially for the particular problem you are solving, it's very easy to do it. And here it's just, rotate it, RS plus RT plus ST. And here basically 3, you have all the 3 cyclic product sum is just RST. That's the only possible way. So basically it's very easy to write out the, like, cubic one. Even the quadratic one is still very easy to find out. The quadratic one is just R plus S plus T plus U, and equals B over A, then negative B over A. Then the next one you actually have 6 terms. You just, write all the combination of picking 2 products. Then the next one you have like 4 terms. Last one you have 1 term. You can write it out. Then trying to, so the first thing is I just write it out. So, I don't have to write this if I have to do it myself. Then I can just write out this directly. Then just use the condition of the given condition. For example, the 2 root add to 0. So basically add to 0, basically you have a lot of things you can do. You can express one root with the other. One thing you can do. The other thing is that because you only have 3, root, and two of them cancel out. The last one actually can be calculable. You can calculate out. Then basically you just fill in more information and take advantage of each coefficient, because each coefficient correlated to a different cyclic sum, and it actually has more conditions. So basically it will, if you propagate the information down into every function, then eventually we'll get it. Yeah. Okay, I think let me stop here, because those problems are not, I think we'll just do one problem each, like each time that on different classes, because it's realistically speaking, it's kind of just, I will say it's not top difficult, it's just difficult in terms of complexity. But the idea is very simple. Idea is just matching coefficient and produce a lot of formula, especially in high, like in quadratic you have 2 formula, in cubic you have 3 formula, in quartic you have like 4 formula. So basically I think usually we'll never go above 4. So basically then you will be able to fill in the information and do it. So I think we have to spread our knowledge into geometry. So let me start the topic of geometry, and then geometry actually about 3 class, and we will have then geometry is relatively fun and consistent and easy. I think it actually has much less information, and so it should be much more pleasant to handle. Let's get that started. Let me use the PDF file off from the this is the okay. So geometry, although thing you already know, I'm going to go through very fast. Yeah, this is just terminology. If your linear angle is the angle share one side and the other side are opposite ray, and vertical angles, these are supplementary, this is the same. And vertical angle, basically, those are made up of angle of 2 opposite rays. Then this is ulterior internal angle, AIA, AEA, alternate exterior angles. Those are used to judge the parallel line, also has corresponding angle. So then equilateral, isosceles, scaling, those are the classification of the angle, acute, right, obtuse. And then this is the triangle sans theorem. You just have to remember how it's going to be proved. So it's just help you out. You just draw a parallel line to the base. Then because alternate interior angle of 1 and 5, alternate interior angle of 3 and 4, you actually is able to combine 3 angle into a single line. So that's add together to be 180. And then this is the triangle inequality. That's quite important. A plus B plus C, or A plus B is greater than C. So basically, it's very easy to, and actually, I don't think there's a proof. This is just axiom, and it's taken for granted, because between 2 dots, the closest point is the line segments, and all the other thing will be longer than that. It's just quite intuitive. And then this is actually a derived derived fact. So you have to understand not just A plus B greater than C, it's also A greater than B minus C. And how do we get this formula? Because we just minus B on both sides. We have A plus B greater than C. If we just minus B on both sides, we will reach this formula. So, and then the exterior angle is the extension, and the exterior angle equal the sum of the two remote interior angles. So this A is supplement to B, and those three angles add up to 180, and those two add up to 180. That's why the exterior angle is the sum of two remote interior angle. Those are used in angle chasing, and then there's an exterior angle. Actually, this formula, I like it more than this formula. There are two formula on the polygons, and and usually we are dealing with the convex polygons, and then basically the sum of the interior angle of a convex polygon, we actually, the interior angle is 180 multiply n minus 2. It is, and I like this formula more because exterior angle, no matter what side of your, no matter how many side of your polygon always has exterior angle always add up to 360. So this actually is more easy to use. I'm going to show example. And this is the triangle and the polygon. And so this is the trapezoid. Trapezoid basically, has a concept called mid-segment. Mid-segment, trapezoid has one pair of parallel side and one parallel non-parallel usually. And the mid-segment of the midpoint, if you connect the midpoint of non-parallel side, that's the mid-segment. And the mid-segment, the length of the mid-segment is the average of the two base, and it is parallel to both base. So they are parallelogram and rhombus, and so rhombus is just a special case of parallelogram, and all the sides are the same. So those are all the sides of the rhombus are congruent, and their diagonal are perpendicular, and then the rectangle, basically the angle, the corner angle are the same. Then more special case is the square. The kite is that just two adjacent sides are the same. Then they have diagonal perpendicular, and one of the, so the 2 point, this point and this point is called the vertex angle, and these 2 points are not. Only where the two congruent side join, it's called vertex angle. The diagonal connecting the two vertex angle will bisect those two vertex angle, and also going to bisect the opposite diagonals. So for both rhombus and kite, you actually have a formula to calculate the area, just 1/2 of the length, 1/2 of the product of the, the length of the diagonal will be the area. And then let me just begin to do several problems, just showing how to use, like especially in the context you actually will have to calculate like angle, regular angle, and how are we going to deal with this type of problem. And usually I use exterior angle sun is 360. It's actually much easier. Let me just do several problems. And so so basically, in the regular octagon ABCD, let me copy a regular octagon from internet. So this problem, for it's asking, let's label A, B, C, D, E, F, G, H. It's asking what is the angle of ACH. ACH. And so ACH actually there are several ways of solving this problem. I'm going to show several, then we'll it's a fun topic. So basically, if I am going to do this problem, I will understand that this is actually, you can, for regular octagon, you can draw a circle on it. So you can draw a circle that just tangent. You can draw a circumcircle on this regular octagon, and then you can actually draw with the circle center, you actually can draw sector like this. And each sector has 1/8 of the angle. So basically it's actually 45 degree. And this is the central angle. And this is called inscribed angle. Inscribed angle on the same arc is actually going to be 1/2 of it. So basically it should be 22.5. So basically I am using a circle, circumcircle to solve this problem. And this is one of the topic we are going to, I actually picked this problem, just show you the diversity of the using the geometry that you actually can, especially like regular gun. And a lot of time, if you incorporate a circle into it, it's actually easier to do. So let me just do another way without using a, circumcircle. If I'm not using a circumcircle, then basically, I know that, let's try to calculate exterior angle. I'm not going to calculate interior angle. Usually always easier to calculate exterior angle. So I know the total of the exterior angle is 360. I can extend this line. So I got this exterior angle. because I have 8 exterior angle, a total of all 8 is 360. So 360 divided by 8 is actually equal to 45. So basically this angle is 45. And so I am able to know that this is 45 going to be same as this angle because this is parallel line. This is top, this is parallel. And why it is parallel? Because it is a trapezoid. How can I tell this is a trapezoid? Because this angle and this angle is the same. And the length of this is the same. So basically I know that this is a isosceles trapezoid with the equal leg. So if you have equal angle, equal base angle here, equal leg here, it will produce a isosceles. So when you see that it is 45, this is also 45. And then I can calculate this because this is isosceles triangle. Isosceles triangle, so basically, I know this 45 is the exterior angle, and those two, let me use a different color. Those two are isosceles triangles, two interior angles. Those two red one will add up to 45. And because those are the same, so it is 25, 22.5. So this red one is 22.5. This green one is 45. You minus it, it's going to be 22.5. So basically, I can use the geometry of the, like, the circle. So I get this extremely fast using the circle, inscribed circle angle. And use this, I'm not using inscribed circle, I'm using the, I am using the exterior angle divided by 8, then use the parallel relationship. And I also using the isosceles nature of the, regular guns like adjacent side, then I am able to get this. So basically there are a bunch of ways to do it, but just remember that, when doing this, exterior angle is much easier to use than the interior angle. Let's just do one more problem, just showing, the benefit of using exterior angle instead of the exterior. So this one is in the section of regular polygon below the measure of the angle ACB. So ACB is 5 degrees. So this is a tiny degree, 5 degree. And this is 5 centimeter. What is the perimeter of this polygon? So I'm only viewing a very small portion of this polygon, but because this is a regular polygon, so AB equals ABC. And this is 5, this is also 5. And this is the exterior angle. 5 plus 5 equal to 10. So the exterior angle is 10. So when I know the exterior angle is 10, I know the total of the exterior angle 360. I know it's 36 gone. It's asking the parameter of the polygon. So 36 multiply 5 is actually equal to 180. So the parameter of this polygon is 180. So you can do this really fast. And so related to, and There are other problems. I don't think those are very difficult problems. So that, if you really do it, it's quite easy. Let me go to on the circle one, and then basically, you will ask, how do I get this? This possibly you will baffled by my trick. How do I use the circumcircle to calculate a not so obvious fact of another angle? So this angle, have nothing to do with this angle. How can I tell this angle? This angle is half the size of this central angle. You possibly will be baffled by this, but I'm going to show you why. And they actually have a special name for this called inscribed angle. And if you have a circle on it. So yeah, we actually getting to the topic of the circle. So to deal with circle, we have to know all the terminology of it. So if you have a segment, that's sitting on the side, sitting on the circumference of the circle, it's called chord. And this is a line segment. And then you can have a line that just touching exactly one point on the circle. Outside of the circle, then this line is called tangent line. And you can also have, this is a chord, basically a secant line is just a chord extending above the circumference of this circle. This is called a secant line. And so I don't think it actually do a very good terminology of the, so let me open another file. So basically, let me just, trying to explain the terminology of the circle better, because this is not a good article on the terminology of the circle. Yeah, this is a better introduction of the circle. A circle is just a collection of the points at equal distance to a center. So this is O. O is the center of the circle. And usually you use the center to label the circle. And then if you have a line pass through the center, it's called diameter. Like AB is the diameter. Then half of the diameter, if you just from the center to one point on the circle, it's called a radius. And chord is like a segment, both endpoints sitting on the circle. So that's a chord. AC is a chord. And a tangent line L, it just touch the circle exactly at one point. A secant line is a line, which pass through the circle. Actually, AC is a line segment, but if you extend AC, it is actually a secant. And then there are more things that, this is arc. Arc is just part of the curve of it on the circle. Is called the arc. For example, we can say arc AC. Arc could be minor or major. For example, AC is a minor arc, and AC going this way is a major arc. When you have difficulty to express the major arc, you can say arc ABC. So basically, people know exactly you are going this way to name the major arc. Then there's another shape is called sector. Sector is the shape that enclosed by a piece of arc plus 2 radius. Then, this shape, the 2 radius actually form an angle. So that is a central angle. And then we have another shape called circular segment. And circular segment, it's very easy to distinguish a sector versus a segment, because a circular segment is made up of a arc plus a line segment. So basically you are you're cutting off a piece of the circular segment by a line segment. So that way, you won't, when people talk about circular segment, you will not mix it up with a sector. Another way to remember the sector is made up of the, 2 radius is actually, there's a C here, sector, SEC. So C means the center. So basically, and like circular segment, there's no C here. There's no, so there's a like tricky distinguish between the name in the letter. You actually can made up of the memory trick to remember the right shape, and you can remember the right shape with the right terminology and never mix them up. So the circumference of the circumference of the circle is actually pi d. Actually, pi is defined by a ratio of, pi's definition is the ratio between circumference and diameter. So that's where this, formula come about. Then if you replace the diameter with 2r, basically, c equals 2 pi r, then that's the circumference formula. Then also the area formula is pi r square. So this is a much better, like, introduction of the circles terminology. Okay, so we are going to the circles track. Circle has a lot of tracks. So basically, we kind of just had to understand it all and understand them all, and to really be good at, test. Just like the previous example I picked, that you can use circle to solve a polygon problem. And so what trick I'm using is I'm using an inscribed angle. An inscribed angle is an angle with its vertex and endpoint on the circumference of the circle. So, an angle is named by its vertex and the, endpoint. And so the angle has 2 endpoints plus a vertex, and all those actually sit on a circle, then it's called inscribed angle. And the size of the inscribed angle is actually, size of the inscribed angle is half the size of the arc. So people measure arc by the angle, because the arc, the size of the arc is proportional to the size of the central angle it's facing. And take to the limit, basically, if you make a full circle, the angle is 360 degrees, or in more of the geometries, in geometry, actually people more and more measure the angle by the radian, and then that actually is 2 pi, because the radian is defined by the ratio of the arc length versus the circumference. So, and so here is actually a very simple proof that, you know, inscribed angle. So here inscribed angle, for example, I have this is a special case which the inscribed angle, I can make the inscribed angle that one side actually passing through the center of the circle. If I deliberately make the angle this way, I actually have the center angle is here is C. Then the inscribed angle is actually A, because this XY and WY are both radius. So basically, you know, WYX is a isosceles triangle. Isosceles triangle, so A and E are equal. Because A plus E equal to C. C is the exterior angle. So basically, you know, A equal 1/2 of the C. So this is actually very, you know, obvious picture, just, you know, proving it's a special case. It didn't include all the case, but other case you can easily extend this fact to other case. So basically, you know, so with this fact, this is actually very important, very, very, very important fact. So I think in the competition, you possibly will face it, or the, you know, just has this type of the problem, and don't even realize there's a circle on it, and give you a lot of information. But this is where the information is, and you have to call it out easily. And so because A and E are identical, and it's add up to the exterior angle of C, so basically A equal to 1/2 C. And this is just, you know, it happened to pass through the, but you can actually, I can actually draw other, I can draw this. So this angle, because it's actually intercepting, this angle intercepting the same arc. So this angle will have the same value as A. So no matter how I draw it, it's going to be the same. So this angle still going to be the same as A. And it's very easy to prove it. For example, I'm proving this angle is equal to this. I can actually easily add an extra line here. I add an extra line here, pass through the center. Then I can say that this, let me use a different color. And this angle, it's actually twice this angle, because this angle plus this angle is those are two interior angles. Those two interior angles are, total of them are the same as this one. And let me use a further different color, and those two angles in this triangle will add up to this one. So basically, you know, then basically after I split this angle into 1/2, each, not 1/2, actually is split into two. Any two of those angles are equal to 1/2 of the corresponding angle here facing this arc. So the total of this angle is 1/2 of the center angle facing this arc. So basically, you know, it's a fairly easy proof. and this angle not passing, not including this, you still can prove it. So this is the most difficult case. We still can prove it. So basically, I'm not trying to prove it here, and I'm going to, there's an article. I'm going to send you the article. Let me show you where the proof is. The other one is actually a so these are very important factor of the let me see. Yeah, here it actually has the inscribed angle is half of it. Inscribed angle ACB, theta. Theta is 1/2 of this center angle AOB, phi. So basically, here we actually have a complete proof. It's actually quite lengthy, and but in the middle, it's all quite easy. It's just trying to identify the relationship between the sides, because the circle has the same radius. It actually will create a whole lot of the isosceles triangles, and use the angle relationship, angle sum, you're able to prove it. So this is the most difficult case. The two other case, so this is one case, then the two other case, we just mentioned it here, it's even easier to prove. So this is the proof of the, and so inscribed angle is a major concept we introduced today based on this problem, and then it just has very wide usage, and if you do angle chasing, it's actually give you a lot of information. If you cannot fail to identify it, you just cannot do the problem. And then there are tangent lines. So there are several important facts on the relationship of the circle and its chord, and the tangent is that the tangent of a circle is perpendicular to its the perpendicular line of the tangent actually will pass through the center. So that's one of the fact. Then also the perpendicular bisector of the chord actually will pass through the center. It's the radius. If the radius bisect a chord, then they will be perpendicular. Then here the measure of inscribed angle is equal to half the measure of the intercepted arc. The intercepted arc basically have a center angle. And this one is at yeah, this is the proof. These are several cases that expand. So inscribed angle, this is just one way of looking at it. Then there's a special case that how about its tangent? So inscribed angle is actually the vertex sitting on it, then it's actually has two chord. And this is a special case that it has, how about it has one tangent and one chord? And if it has a one tangent and one chord, basically this arc B, and this is angle A. And angle A is 1/2 of arc B. So basically here has the, so arc B will be twice as big as the tangent angle here. This is the tangent line, and this is one chord. And the angle formed by, this is A. A is 1/2 of the cutoff arc from the tangent point. And this is the other chord point. Then this is a secant line. So basically a inscribed angle has the angle that just touching the circle. How about two secant lines that goes above the circle and intersect outside of the circle? They actually have special relationships that like the angle created by this A, it is outside of this shape. A is actually 1/2 the bigger arc and the small arc. So the difference of bigger arc and the small arc equal 1/2 C minus B. So this is the one. And then there's an intersecting chord. So how about it's not intersecting outside if the two chords intersect within the circle. And if it is within the circle, intersecting chord angle C is actually equal to A plus B. So this is the arc A and arc B. Arc A plus arc B divided by 2. So this is the intersecting. So this is actually a very, very intriguing fact. And so going back to the problem we have been solved, yeah, going back to this problem we have been solved. So it's a regular pentagon. We can put a circle on it, put a circle on it. So all those vertex of the regular octagon actually, touches the circle, and all the angle you actually made by connecting the vertex is actually, some type of the inscribed angle. So basically, this angle, it's telling you to calculate basically ACH. ACH is actually 22.5. Then let's just make more angle and trying to calculate more angle on it. So basically, you will see that magical thing happen, especially in regular GAN, is that you are able to calculate those angle. For example, the center angle for every side is the same, is 45 degree, because it's a regular GAN. So AB, if I put an O here, AOB is 45, BOC is 45, COD is 45. So it so goes on and on. And so basically, if I use just the concept of the inscribed circle, then this is actually, because AB, arc of AB, arc AB is 45 degree. So this inscribed triangle angle here is 22.5. And I don't even have to use the isosceles triangle to find it out. Then this is also the same. ACH is 22.5. Then actually, HCG is also 22.5 because this is the same arc with the same size here and here. And this is also the same. This is also 22.5, 22.5, 22.5. So basically, that's why I was, trying to give you more insight into how this information is related to regular GAN. And given the circumscribed circle and your information on the regular GAN is much more rich, and it's just magically, create so many equal angle like a fan, and that is quite beautiful. So let's finish the circle part. We still have a lot of things. So a lot of practice actually based on different, angle circle relationship. Let's today at least finish the circle part. We will have several classes on the geometry, but today we're going to be more on the regular GANs and the circles. And this is a fun topic actually. So this is the parallel line. So two parallel line will actually intercept the same arc. So arc A and arc B, they are intercept on the circle by parallel lines. They will for sure will be equal. And it's actually quite easy to prove. Let's see the proof of it. The proof of it, you just connect tip from here to here. And so because it's a parallel line, so those two are alternate interior angle, and those two angles are the same. And so those two angles are 1/2 A and 1/2 B. And if 1/2 A equals 1/2 B, that means just A equal to B. So basically, the parallel line will intercept the same circle with the same arc length. Then this one is the cyclical quadrilateral. Cyclical quadrilateral just means that, so a quadrilateral with all vertices located on the circumference of the circle. So this is a special quadrilateral, and the special point on it is the opposite side are supplementary. So W plus Y equals 180, and Z plus X will be 180. So basically, 1 plus B, it says that. So they have supplementary relationship between the opposite angles. Yeah, so there are a lot of, yeah, so this one, we can just do 1 or 2 problem trying to find out, how to do this type of problem. And let's just do 1 problem, try to find out. So it looks like this is a tangent line. And so basically, we can tell that this actually, this is a tangent line, this is a secant line, and it's actually cut the whole circle into 3 arcs. So this is arc 1. Let's say this is A, B, C, and D. So basically, we have arc AC, and we have arc AD. We have arc CD. And if we add them up, it's going to be 360 degree. And then this is 35. So angle B equals 35. And so angle B, because it's outside of the circle, it is just, 1/2 of the arc AC minus arc AD. So basically that's, and it's actually, let me try to find the arc X. So arc X is here. And so 1/2 arc AC minus AD equals to 35. So arc AC minus arc AD actually equal to 70. And this, by the way, I have never done this problem. Let me see. It's not, let me see, find each arc, measure X or angle in the, so this is a tangent. Oh yeah, I saw. So there's also a, there's also a tick, means that this circle is the same. So this obviously has a mark here, also mark here. So basically this is 35, this is also 35. So this is 35, means that this is 70. So basically this is the same center angle. This is inscribed angle. So this is 35. So this is 70. So this arc is 70. So basically, AD equals 70. So this is 70. AD equals 70. So this is 70. AC equals 140. So AC equal to 140. That's 70. And then the remaining, it's asking the X. X will be like, 360 minus the, let me see if it's right or not. So basically, those add together, 140 plus 70 equals 210. And so X going to be equal to 150. So that's the measure of it. Yeah. So this type of problem, you will just have to, label the side and with all the information. Labeling because the way I find out it is that I find it to take here. So basically I can map it here. Then I can find AD is 70. And so this is the outside angle. With the outside angle, it's actually, the two arc AC minus AD equals to 70. So that's actually, help me to solve it. Let's see. Yeah, let's finish the arc. So circumference and the arc length. And so the circumference is 2 pi r. That's very obvious. Then the arc length, to try to calculate the arc length, we will just use the angle and do the proportion work. For example, half circle is 1/2 of the half circle. The radian measure is actually pi, so it will be 1/2 of the circumference. And here, for example, this is when we're trying to measure the perimeter of those 3 circles that tangent to each other, and not including the inside thing. And what we do is that we actually is able to draw a equilateral triangle. We find out that the missing degree of the arc is 60 degree, or 1/6 of it. So the remaining one is 5/6 of it. So 3 multiply 5/6 and multiply 12 pi. So that's the way we calculate it. Yeah, the arc length is usually just proportion. For this one, it's just you are each one missing 1/4. So that's about it. And congruent triangle. Yeah. Okay, I think we reached the stop point, and today we kind of go through the geometry. We put most of the emphasis on the we put most emphasis on the a regular gun plus the circle, and we introduce the theorem on the inscribed circle. And the inscribed circle is 1/2 of the center angle. And I'm going to send you the homework, trying to practice on it, and try to do as much as possible. And I think that should conclude today's lesson. And have a nice day, everyone.